Section 9.1, 9.2, Quadratic Functions. Today's objective is to graph a quadratic function in the form y equals ax squared plus bx plus c. So our first key concept is standard form of a quadratic function. A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a does not equal 0. This form is called standard form of a quadratic function. So this is the most standard form, meaning this is the general shape or style that the equation will come in. Some examples of this are y equals 3x squared, y equals x squared plus 9, and y equals x squared minus x minus 2. Now we've got some key concepts we need to be aware of. We've got parabola, which is a U-shaped curve graph of a quadratic function. And then we have axis of symmetry. The axis of symmetry is a vertical line that divides the parabola into two symmetrical halves. So in the case of this example here, if we were to break this or split this parabola with its axis of symmetry, we're going to try to find a symmetrical half, which is going to be the y-axis here. So simply put, if we were trying to fold this parabola over on itself, the two halves would line up perfectly. So this purple line represents your axis of symmetry. The vertex is the highest or lowest point on a parabola. When looking at a parabola, if your parabola has a high point or your vertex is at the top, we call this a maximum. If it's at the bottom or of the parabola, it's called a minimum. So if a parabola opens upward and the vertex is the lowest point, then you have a minimum. So lowest point, we call that a minimum. If your parabola opens downward, the vertex is the highest point, and we call this a maximum. Another way to think of this is minimums are kind of like valleys, where maximums are kind of like the top of a hill. So we've got valleys, we've got mountains or hills, and so that's kind of a nice way to remember it. We want to identify the vertex of each parabola and then give the max or min value of the function. So in this case, we are looking at finding the vertex. And so for the first one, I know the vertex is right here. And our vertex is at the point, in this case, -3, 2. And because it's at the bottom of the parabola, this would be a minimum. We'll do the same thing in the next example. Well, I know my vertex is right here. That's at the point, what is that, 2, 5? And because it's at the top of the parabola, this would be a maximum. In example 3, we're doing the same thing. We're going to look at finding the vertex. In this case, we have a vertex right here. So in this case, our vertex is at the point -2, 5. And in this case, it's at the top, so we have a maximum. And our maximum is at 5 for y. So our maximum would be at the value for y equals 5. And so our vertex is -2, 5, and we have a maximum. Something important to keep in mind is that when you have a quadratic function in the form y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. So looking at these following examples, you can see how each of them has a different location for their axis of symmetry because of the varying values of their b term. Finding the axis of symmetry by using a formula. So we have a formula for the axis of symmetry. That formula is x equals -b over 2a. And this formula is used whenever you have your quadratic function in the form y equals ax squared plus bx plus c. And all you're doing is you're taking your values for b and a and plugging them in order to find what your axis of symmetry equation would be. So in this case, for the example here, we've got y equals 2x squared plus 4x plus 5. They've taken the value of b, which is 4, and they've plugged it in. And in the value of a, which is 2, and plugged it in. So you've got essentially negative 4 over 4, which gives you negative 1. So the axis of symmetry is x equals negative 1. All right, so let's try this on our own. And the nice thing about finding the axis of symmetry is it allows you to also find your vertex using that value. And so we'll look at that right after we find the axis of symmetry. So in this case, our axis of symmetry formula is x equals negative b over 2a. And so we plug in our values for b and a. So I've got negative 4 over 2 times 1. So negative 4 divided by 2 is negative 2. So my axis of symmetry equation is x equals negative 2. And this will give me a vertical line at negative 2, and that's kind of what I want for the axis of symmetry. Now I'm going to look at finding the value of our vertex, or to find our vertex. But right now we already know the x value of our vertex. It's negative 2. What we're missing from the vertex coordinate point is our y value. So in order to find the value for y, we're going to plug the axis of symmetry value in for x into the original equation. So I've got negative 2 squared plus 4 times negative 2 minus 8. And so when I solve this for y, I get the y value to equal negative 12. And so that means the y value of my vertex is negative 12. So my actual vertex in coordinate points is negative 2, negative 12. And so I take the axis of symmetry and I take the y value I get back, put them together to become my vertex. All right, let's try another example. We've got y equals 0.25x squared plus 2x plus 3. So same idea here. We want to find our axis of symmetry first. So x equals negative b over 2a. So I've got b, I've got a. So I've got negative 2 over 2 times 0.25. Well, 2 times 0.25 is 0.5. And then negative 2 divided by 0.5, well, that's going to be a negative 4. So our axis of symmetry becomes x equals negative 4. And now we're going to take that value and we're going to plug it in to our equation to find y. So we've got we got 0.25 times negative 4 squared plus 2 times negative 4 plus 3. Now we just want to evaluate this to find out what y equals. Well, in this case, y should equal negative 1. And so that means that our vertex for this equation or for this parabola would be the point negative 4, negative 1. All right, let's try one more of this. We've got the equation y equals 3x squared plus 6x minus 7. We'll start by finding our axis of symmetry again. So negative b over 2a. We've got b, we've got a. So we've got a negative 6 over 2 times negative 3. So that's negative 6 over negative 6, which is a positive 1. So your axis of symmetry is x equals 1. Then we're going to plug that value in for y, or in for x, to find y. So we've got negative 3 times 1 squared plus 6 times 1 minus 7. We'll go ahead and evaluate all this, and you get y to equal negative 4. So that means that our vertex, in this case, equals 1, negative 4. So that's the coordinate of our vertex for this parabola. So the next thing we're going to do is we're going to tie all this together and use it to graph parabolas on the coordinate plane. And in order to do that, we're going to do this by hand to start off with, just to find key points. We're going to find the axis of symmetry. We're going to use that to find the vertex. And then we're going to find 2 other points. It's easiest if we use the y-intercept as one, and we'll talk about what the y-intercept is in terms of your quadratic equation. And it's actually really easy to find. And then we're going to plot the vertex and our other points in order to create our graph. So let's go through this first example. We've got 3x squared minus 6x plus 1. Let's just go ahead and find our axis of symmetry first. So that means we're going to take x equals negative b over 2a. Well, negative b in this case, instead of being a negative 6, would be a positive 6, because you want the opposite there. And then 2 times 3, it's going to give us a positive 1. So axis of symmetry is x equals 1. So that's helpful. And then we've got our vertex. So we'll plug in 1 and try to solve for y. So y equals 3 times 1 squared minus 6 times 1 plus 1. Well, in this case, our y value is going to equal negative 2. So that means the coordinate of our vertex is actually 1, negative 2. So we've got our axis of symmetry, we've got our vertex, and then it tells us to use our y-intercept. Well, on a parabola, the y-intercept is really easy to find. It's actually just your c term. So in this case, 1 would be our y-intercept, or the point 0, 1. So in this case, our y-intercept is just 1, or the point 0, 1. So for the y-intercept, you've got 1, or the point 0, 1. So right now, what this means is we've actually got 2 points, and we can find the third point pretty easily once we start graphing the points we have. So let's just go ahead and plot our vertex at 1, negative 2. All right, so that's our vertex. We know that our axis of symmetry is at what? X equals 1. So if we think about it, this is our axis of symmetry right here. And what this means is our graph is going to be symmetrical on both the left and the right. So if we plot our y-intercept at 0, 1, which is right here, there should be a mirror image point on the opposite side of this line. So if we think about it, it's 1 away from the axis of symmetry, we go 1 to the other side, we have a mirror image point right here. So right now, we've actually already found 3 points for this parabola. We've got our first point being our vertex, so we've got 1, negative 2. We've got 0, 1 being our y-intercept, and now I've got 2, 1. And this is more than enough points to graph our parabola for right now. So we just need 3 points here to get a general shape. And so that is our parabola. All right, let's try another one. This time I've got negative x squared plus 4x minus 2. So I'm going to find my axis of symmetry. So I've got x equals negative b over 2a. So that's negative 4 over 2 times negative 1. So negative 4 divided by negative 2 is 2. So my axis of symmetry in this case is x equals 2. Then I'm going to plug in that value to find my vertex. So y equals negative 2 squared plus 4 times 2 minus 2. In this case, I'll evaluate my y value, and I'm going to get y to equal positive 2. So that tells me that my vertex has a coordinate of 2, 2. And the last thing I need to find is my axis of symmetry, which we said is the c value for our parabola, which in this case is negative 2, or you can say the point 0, negative 2. So we've got 3 values here that we need to keep in mind when we go to graph this. And so in reality, we actually have almost all of our points. So let's go ahead and plot what we have. We have the vertex at 2, 2. Oop, that's 2, 1. Missed the spot. There we go. 2, 2. There we go. And then we have our intercept at 0, negative 2. Y-intercept's right here. And we keep in mind our axis of symmetry comes down like that. So if a parabola is symmetrical, we have a point on the opposite side, the same distance away from the axis of symmetry, so that way they look like mirror images, and then we can use this to graph our parabola. All right, next one, we've got y equals 2x squared plus 6x plus 2. So for this one, we've got to find our axis of symmetry. So x equals negative b over 2a again. So that's negative 6 over 2 times 2. Negative 6 divided by 4 is a negative 1.5. So our axis of symmetry is going to be x equals negative 1.5. We're then going to use that value to find our y value of our vertex. So we've got y equals 2 times negative 1.5 squared plus 6 times negative 1.5 plus 2. And when we evaluate this, we should get our y value to equal negative 2.5. So that means our vertex in this case is negative 1.5, negative 2.5. So this is our vertex. And the last part of this is our y-intercept, which is in this case is a positive 2, or we could say the point 0, 2. So we're going to plot what we have so far. We've got our vertex is negative 1.5, so we kind of estimate there. Negative 2.5, so it's right here. And then we've got our intercept at 0, 2, which is way up here. And we know that our axis of symmetry is right here at y or x equals negative 1.5. So to get our third point, we think about the mirror image. And so we want to be symmetrical, so we go left towards our axis of symmetry, and we extend it another 1.5 to the other side. Gives us another point there, and we just plot our points. Now we connect our points to make our parabola, we round it off, and that's our parabola. So we are using essentially the axis of symmetry, vertex, y-intercept, and then another point that you get because parabolas are symmetrical to graph your shape. If for some reason you're having a hard time finding the points for the parabola, or this doesn't make a whole lot of sense, remember you can use the graphing calculator's table feature to look at points of your parabola. You can also use it to check to make sure your parabola has the right shape. All right, our last problem is a word problem. The height and feet of a basketball that is thrown can be modeled by the function f of x equals negative 16x squared plus 32x, where x is the time in seconds after it is thrown. Find the basketball's maximum height and the time it takes the basketball to reach that height. So we're looking for two things, and we have to know what each of these things means. So max height, when you think about the maximum height of something, or at least in a parabola-shaped graph, the max height is actually going to be your y value of your vertex. Okay, so y value of a vertex, where the time to max would be your x value. Okay, so we're actually going to find, or keep doing the same things we've been doing. We're going to find the axis of symmetry, which in this case will answer this one for us. And then the y value will answer the height when we plug the axis of symmetry back in. So let's just go ahead and find the axis of symmetry. So x equals negative b over 2a. Well, our b value is 32, so we want a negative 32. And then 2 times a, well, a is negative 16. So we've got 2 times negative 16. So that's negative 32 over negative 32, which is positive 1. So it reaches its max height after 1 second. Now to find our max height, we plug the 1 in for x into the original equation. So we've got negative 16 times 1 squared plus 32 times 1. And we evaluate. Well, negative 16 times 1 squared is negative 16, plus 32 would give you a positive 16. So this is 16 feet. So we've got time, and we've got max height.